All right. Hello, folks, and welcome to another edition of The Binding Status. My name is Dan Mangum. I'm your host every other week. And I'm joined today again by Muvaffak, who is a fellow maintainer of the Crossplane project and specifically has done a lot of work on some of our different providers, especially provider AWS. Muvaffak's been on TBS before. And I believe last time we implemented a GCP pub sub resource during the show to kind of get folks up to speed how they could contribute new resource types. Today, we're going to be looking specifically at provider AWS and a lot of the work Muvaffak has done around enabling using a shared code generation pipeline with ACK, which is the AWS Controllers for Kubernetes project. And so, yeah, Muvaffak, I'm going to go ahead and hand it off to you and let you give yourself any introduction you think is necessary. And then we're going to jump right into it because this is going to be a really contributor focused episode, and we want to show how everything works.
Yeah, thanks, Dan. That was a pretty good summary. I'm Muvaffak, and I've been maintainer at Crossplane, I think now 1.5 years. In the last episode, we implemented the resource in GCP, but like if folks remember it, like there was a lot of plumbing there that could be automated. So collaborating with AWS, we actually hooked up a Crossplane pipeline into their code generation pipeline, and now we are able to generate most of those plumbing parts. So today I want to just go ahead and implement a resource, which will be EFS, Amazon EFS resource file system.
Awesome. Yeah, go ahead and feel free to share your screen. While you're doing that, I have a, well, first I'll say, per usual, if anyone who's watching from home, feel free to drop your name in the chat and let us know where you're joining from and ask questions as we go along. Another thing, Muvaffak, I wanted to ask kind of just for my own edification, what is the source that this code is being generated from, right? Like what is the obviously we have a pipeline to turn something into Crossplane resources. What is that something?
Yeah, that's a good question. So the AWS is SDK itself, Go SDK, is also actually generated, and the source for all of these code generation is like JSON file, like a one API JSON file. Like the parts that I've seen was like Go code basically, but I believe the same JSON file is used in for other SDK codes as well, like JavaScript and other languages basically. So it's a JSON API schema that we're generating. I think it is not open API schema. It's like in-house AWS format. But yeah, all their code generators work on that JSON.
Nice.
Yeah. Right, cool. Should I just start?
Yeah, go for it.
Yep. All right, so the first step is basically, well, look for the issue related to that resource type. And we are seeing that, there's like implement EFS service here. Someone from the community opened, allow EFS volumes. Cool. So the first step is basically like letting others know that you're working on it. So maybe a comment would be helpful here, and then we can assign it to you as the maintainers of the repo. Just a quick message there, and I'll just assign it to myself. Or you can ask about it in Slack, and he would tell you where to start and stuff. But the main document that we're following is this code generation MD in the repo in top level. So this is step by step how you can use the code generator from AWS to generate the parts that can be automated. The first step is essentially we need to clone the code generator. We will make this part of our make file, so you don't have to do that for now at least. We need to have it in local. which is here right now. The repo is also here, as you can see. All right, so the command that we need to run requires service ID and also the provider AWS directory as the output directory. And the list for like service ID is here in the ACK, in the AWS SDK repo. You can see the first word is what we're going to use, and I think it is EFS for this service.
Yeah, and an important thing to note here that folks may not be aware of, there's two variations of the AWS SDK for Go. So all of the code generation we're doing today is with the V1 version. And that's kind of a decision that I believe was made in the ACK project to standardize on that. We also have some resources that, as Muvaffak points out there, use the V2 version. And that also, I believe, recently hit 1.0. But something to keep in mind that any of this code generation for the time being will be done with the V1 SDK.
Yeah, that's true. All right, cool. So we have found our API Service ID Elastic File System, which is as expected. So I will just copy paste this one. So my provider AWS is here in my local, and then I will just change the service ID to Elastic File System. Well, first let's open a new branch. Cool. So I will just hit go run and we will see. Well, that's cool. We have a little bug, I believe. Actually, I will not go into detail to fix this because I have some fixes in this other branch with other PRs. So maybe because I have like a few PRs open there, but they didn't get to make it yet. So I will just use this latest.
Cool. And yeah, folks can look at this branch. I just dropped a link to the repo in the chat. So definitely feel free to check out Muvaffak's open PRs there.
Okay, cool. I guess it was some problem with the service ID. With EFS, it works. Okay, cool. So the generation added two folders, one to APIs EFS, which has CRD types, and one is the actual controller implementation. So we are going to go to here by IDE, here EFS, and you can see there is like access point, CRD, file system, and also mount target. So we have like three of them, but we actually want to implement only the file system one for now. So what we're going to do is to let code generator know that we want to skip others. Due to like the code generator and AWS Go SDK works on like service level, not resource level. For example, when you generate RDS, it generates like, DB cluster, DB instance, subnet groups, and all that stuff. But we want to ignore some of those. So we will write a generator config.yaml here in the output directory. And by the way, I'm still following this. This is like the next step. Essentially copy and paste this one. Okay, so what I want to ignore is access point and mount target. So when I run the generator with this configuration, and that's also documented, it doesn't delete the old ones because it doesn't know about them. So what we need to do is basically like, delete everything that is generated except like, the YAML that we just wrote. So which would be package controller EFS folder as well. So let's head back to our terminal. Okay, so we will run the same command again, but now it will only generate the file system. Cool. Okay, now we get back and we see only the file system here. Getting back to document here. So the one step is ACK generation, which has like the whole CRD structs here and the types like used in that CRD, and also the controller implementation here. As you can see, like as usual, we use a generic reconciler in Crossplane. So we have to implement like actually four functions only: observe, create, update, and delete. And all of this is generated right now for us. But this is only like the AWS part. We need to run our both Kubernetes, like kube builder generation tools, and also Crossplane generation tools, so that these interfaces are actually satisfied.
Yeah.
In order
Yeah. I
to,
think that's, sorry to interrupt, but I think that's a really good point here. There's the, generating the structs is kind of the first part of this in the pipeline. But then there is the standard interfaces that basically have to be satisfied for a Kubernetes object. And that's things I believe like getting the type meta, getting, GVK, that sort of thing. And then you mentioned the manage reconciler there, which is part of Crossplane runtime. And that's like our opinionated thing, which I'm sure you're going to get more into those CRUD methods that we can pass to it. But I feel like one of the things I love about this generation process is it really shows the power of the manage reconciler, because really the only parts you have to edit manually are those CRUD methods.
yeah, exactly. Yeah, so we will get into these parts as well. One thing we need to do right now is that, as you can see, there is a custom file system parameters here. Like it doesn't have a struct yet. This is like in order to add custom fields to the CR, basically. The fields that for some reason ACK didn't generate. So we will, for now, in order to be able to compile the code, we will just create it as an empty parameters. And then we will see like, how it's useful in certain cases. Okay, empty for now.
Gotcha. So you usually, with any of these fields that the SDK doesn't generate, is
Yeah.
that just due to the nesting strategy? Does it generate any of the nested structs or just the top level?
So it generates all of it, like, recursively. You
Mhm.
see, we have like, fields here, but we also have this tag struct generated in ZZ tabs,
Gotcha.
ZZ types. So this is more like, useful. For example, you see KMS key ID here.
Hmm.
We will add like its reference and selector fields in custom files and parameters.
Gotcha. Okay. So,
Yeah.
oh, and I see. So this is an inline struct that's basically saying these are all the cross-plane specific things that we add on to manage resources in the spec, right?
Yeah, exactly. Like
Cool.
ACK doesn't have any kind of like reference or selector mechanisms, but in Crossplane we do. So we will add them like, via this struct. I have a PR that actually lets you like, point to KMS key ID here and say, hey, this could be a KMS managed resource reference. So that it generates those fields as well, but it's not merged yet. So we have to do this, custom parts right now.
Cool.
Cool, so now we got it compiling. So we will now run the generate part. So actually the command itself is only make generate, but due to Upbound like build submodule, I have to overwrite my Go supported versions to 1.15, and due to some change, a recent change about private registries, I have to overwrite this as well. So, but for normal local environments, it should be just make generate.
Yeah, I'm currently using a fork of the build submodule on all of mine because we need to update that value. But basically, if you're using something 1.15 plus, just go ahead and set that environment variable, and we'll make sure to get that sorted out.
Yeah. So now I'm running our own generation processes, and we will see like 3 files here. basically like, injecting methods to file system CRD. This is like standard kube builder. This is Crossplane manager resource interface functions. Cool. So my IDE does not recognize these new generated functions really well. That's why it says like, it doesn't implement runtime objects. I will just close and open it up. Yeah. That's technology.
I was just about to say, I was doing a stream last night and I was on VS Code, which I think is probably even worse about this, but I just kept opening it and closing it to try and get the squiggly lines to go away.
Yeah. All right, cool. So we got that part. It's all good in compiling. Let's see the controller code. If there's any like red lines here, which is fine. And there's also the conversions, which I will get to in a minute. But what I just want to get back to the document here. So now we come to like custom parts. The automated parts are all completed and done. In this step, we will need to register the controller that we generated to the main manager of the controller's runtime. So this will be our method to do that. So we will implement our custom functions here in a file called setup.go. This is obviously like from another managed resource. So we will just change the stage with file system. Yeah. And this API tab, this should also be EFS. Cool.
Also, something to note here on moving forward, we'll also need to drop the rate limiter in there with the recent update in the setup.
This one?
Yeah. So if you open up one of the other, I guess any of the other packages there in the setup, it should have just after name, it should have like, yeah, there you see with options rate limiter up there. If you just drop that
this one.
Yeah, exactly. I can update the doc. I think I did update the doc actually. So maybe let me take a look. I did not. So I will make sure to follow up with that.
Okay, yeah.
Cool.
So limiter here. Cool. So we will call this setup file system here in the main registration function. Just copy this and EFS. Right, file system. Okay, so now we hooked up our controller. So when provider AWS comes up, it will actually set up the controller and like start reconciling. So this is like the first step. And there is also the registration of the CRD schema. Since this group is new, we need to also register this one, which is done just here. See, yeah, in APIs, AWS.go. Here, just like similarly, we will have like, I guess this one would be EFS, and then okay. So we're good. Everything is registered now. Let's move to the next step. Yeah, so the referencer field that I just talked about. So that's where the custom parameters start is actually useful. So in Crossplane, we have like, for example, we've got, I believe, KMS key ID here, right? Yeah, here. So like AWS can actually encrypt the file systems with the KMS key that you give, but like having to give the full ARN or ID is not really like an intuitive UX. Since we already have KMS key resource, we can actually refer to like if you provisioned your KMS key using Crossplane, you can just use its like a custom resource name And then this like controller will resolve the actual full ARN or ID or whatever it needs before making the queries. So that's like where these new fields will go is like custom files and parameters. As you notice, we don't touch the files that are generated, the ones that start with ZZ and like underscore. So we will just add them here. Sorry. So we can just copy it from like some other resource. Let's say EKS, or maybe another generated one. Custom types, yeah. For example, this one.
Yeah, I wonder if at some point in the future, I guess we could, it's kind of hard to know some of these references. In fact, I actually ran into one the other day where the GCP API has a number of different, I think it was load balancer types. So they define like a TCP load balancer, an HTTP one. And then there's this backend service object that has a target reference, and it can target any of those different ones I just mentioned there. But what I was going to suggest is, we could potentially in the future, it would not be foolproof, but say like, oh, I see that this field looks like another type that's already in this code base. Do you want to create a reference to it? But that would be kind of like a super optimization at this point. And especially for like the alpha types, if you didn't have a reference, it could still be functional, just not as usable.
Yeah, like I have a PR actually like lets you just like point to the field here in generator config YAML, but it's still up there. So maybe like not full like automated, but like for as long as like which field, it'll generate the parts that I'm just going to write right now.
Nice. That's actually probably a better idea than what I was thinking, because this is just a little more declarative.
Yeah, but like we can hook up like a small tool that like scans and like add to that generator config YAML, so it could work that way too.
Yeah, that's a good point.
All right. Yeah. So referencer fields, we added them. So there are some cases where they are required. For example, if you're gonna, let's say, create a API mapping, you need the API ID, and that's required. But you can also have reference. For reference fields, we cannot have the actual field required, because when people like if a field is required, you cannot like create the resource without that field. But like the point of reference and selected is not having to give that. So in those cases, we add them to ignore clause of like field paths to ignore those fields. So like in this case, KMS key ID would not be generated, and we would have added here too. It would still be the part of like parameters. But we don't need to do it right now because it's already optional, so we're good to go with only 2 fields. So additionally, we need to teach Crossplane to resolve these references. Like, we have a KMS and we know its name, but we need to know like, what actual value from that CR we need to get. It could be full ARN, it could be just a name, like human-friendly name. So here is like a link to an example. A simple example is basically this one. Like we have some like runtime functionality there to make it easier. So we will just copy this and see how it would work for us in a new referencer.go file. So here it won't be stage. Actually, let's just again do the full replace and import context.
Yeah, and what's happening behind the scenes here is this is another benefit of the manage reconciler that kind of does this by default for you. You can actually turn it off as well. But I believe Muvaffak and Nick implemented this a while back, where you can just pass it these fields for current value references, selector, etc. And it basically goes and gets the type from the Kubernetes API. So, whatever, for instance, if it's a reference, it's going to be a name, and they're all cluster scopes, so namespace isn't relevant. And if it's a selector, then it lists them. I'm not sure if there's multiple. I think it just takes the first potentially, or maybe it errors. I'm not sure.
Yeah, if it's like the KMS ID right now is a singular field, so it takes, if it finds more than one, it takes one randomly, just like Kubernetes does.
Hmm.
But if it's like, for example, a subnet ID list, the actual field, and you give a selector, it will add all of the security group IDs to that list.
Yeah, yeah, that's a great point, and that's super useful for folks that have used composition before. When we have the match controller ref and that sort of thing, where
Yeah.
it will basically say if it's in the same composition as this, add it. So if you, I think we have an example with maybe like an RDS instance and 3 subnets in composition, and it basically like adds subnet rules or something like that to allow ingress or something of that matter. I don't think that's actually what's happening, but it basically uses the resources in the same composition.
Yeah, exactly. Okay, so one thing about other than like copying and pasting this resolver is that this extract function. So this is how we let resolver know which field of the key resource to extract. Usually this is like a built-in function, external name. I won't go into like much detail about external name, but like it's usually the identifier that we most of the time need. But in some cases it's not. For example, it could be just name and we might need ARN. So in this case, we need we have to read the description of the field so that we know which format it requires. So it says it could be one of the following, like ID, ARN, alias, or alias ARN. So we will actually go to KMS key implementation and see what is the external name. What is chosen as external name? Let's see. Okay. So we will get into this post create hook, but it's essentially you can just say find here, set external name, and you would see where it is set, and it's directly the global unique identifier for the CMK key ID. So using this reference external name is actually fine in this case. So we don't make any changes there. This is all good and will be called automatically by our managed reconciler.
Yeah. One thing I want to point out, we have a number of folks in the chat. Someone just mentioned, Zyro just mentioned, sounds like you will need a validating webhook if a KMS for a resource is required. So I think what they're getting at there is, we have to make this field, that the actual KMS key ID, for instance, optional. In this case, even if it's required, because at creation time, we don't want it to be rejected by the API server. So you could have a validating webhook. And it's appropriate we have Muvaffak here because he's been looking into webhooks in Crossplane. You could have one that says, it potentially, if this is submitted and this is a certain type of field, which this would be packaged into provider AWS, it could say, make sure that there is a KMS key resource, and maybe it's not ready yet, but essentially let's block it if you haven't created a KMS key or it's not present. But you could also have things where you want it to be created and just wait for it to exist. So there's some different kind of intricacies around that, but that's a great point.
Yeah, I believe what we're going to do, that example is API gateway, where API mapping requires the API ID because it has to know that. Right now, when you create a CR, you can actually create it without API ID or ref or selector. But what I'm thinking about doing it as a validating webhook is to implement a function that will require only at least one of them. So you're free to not give API ID, but if not, you have to give ref or selector. So something. If there is just nothing that you can give, you can't create a resource because it's required. So we will implement a higher level requirement validation there. But for now, it's fine. In all cases, it's kind of fine because after all, AWS just rejects the call. So like you are able to see the error in events or like, status. All right, cool. So we have done this step as the reference resolver. So now we've come to external name. So in Crossplane, we have a notion called external name annotation. For example, here in our implementation, let's see the API struct, EFS file system. Yeah. So here we will, okay. So there are some resources, for example, RDS instance that allows you to actually give a name to RDS instance that you've created. So it appears as a name in the parameters. And then we would have to ignore that and use external name annotation. But in this case, EFS file system does not have a human-friendly name at all. When you create it, it just comes back with that ID that AWS decides for you. So what we are going to do is to set the external name to that ID so that we still have the identifier for all the calls we make. We always use the external name annotation for every call that we make in the controller code. Okay, so in every call that we make, we need to have that ID. So what we are going to do is, let's start with the creation. We have a chance to inject hooks, both pre-create and also post-create here. So the first thing we want to do is basically inject the post-create hook so that we can catch the ID and set it as external name in the annotation. So I will just go, by the way, these are all filled with no op functions here, implemented like return nil kind of style. So I will just create the no op post-create. And change the name and stuff. Just in a minute. Okay. So this is what's going to be called right after creation. So we are getting these two as a result. So what I'm going to do is, if ERR is not null, we don't have anything to do here. We just return error. So what we are going to do is, this is the CR and this is the result, right? We will set the external name of CR to obj.hem. File system. So actually this is one of the edge cases we have a lot of times. So we could use file system ID or ARN, or there is a name. Oh, okay, that's just a tag. We don't need to, we can't use it. So there's both file system ARN and file system ID. The way we decide which one to use, it depends on how we can query other calls. For example, when we set this here to ARN, we need to make sure that our describe call here actually runs with ARN. So we go ahead and see what input it accepts, and we see here it's file system ID. And I believe for update as well, this is the case, because that's usually the case. Here, update call, let's see the input, and yeah, file system IDs are required field and stuff. So we are going to use the file system ID as external resource name. Since this is a pointer, we will use string value, yeah. And right after setting this, we have to let manage reconciler know that we have set a an external name, so that it makes sure it ends up in the API server. Normally, all status updates are propagated automatically, but for spec updates, we have to let it know we have assign an external, so that thanks to this, it will retry if it cannot update, because this information is not something we can lose. Like if we lose it at this point, in the next reconciliation, we will say, hey, there's no external name, so I have to recreate it, a new one. So this makes sure managed reconciler does persist, like, the external name. So this is our hook. Let's, we have a options here in the controller option, so that we can, like, hook up our injected functions. Option array, and there will be only one. So e dot, you can see what's going to be called. So right now I am overriding the no op with my actual implementation of post create. And then I will let these options be considered in the initialization of the controller. Cool. Since I did not use this, I can just that way. All right, so we have the external name set in post create. So after the creation, what's going to happen is, like, describe call. So we have to let the describe as well, like, know about this ID, like use external name annotation as the ID in the, like, describe input struct. So we will say, like, preobserve. Actually, let's copy the implementation. Zoom tab. Okay. Yeah. Preobserve. CR, and this is like the object. So what I'm going to do is just object file system ID should be equal to meta.get external name of this CR. Since this accepts a pointer, we will just use a helper function here to make the conversion. And then we will set it here, e.preobserve. Okay. So now we have injected our, like, external name into, like, observe call before it's made. And we will have to do the same for update as well, update and delete actually. So this is, like, we could, like, generate these parts as well, like integrated, but it required, like, some, like, big changes in ACK. So for now, we're, like, keeping that as the last thing to do, like after getting other stuff. So we will, I believe at some point we'll generate and don't need to overwrite this stuff. But for now, we have to do it. And also Predelete. Okay. Cool. Now I'm going to hook them up. E dot. Cool. Now we have implemented the external name part. So all calls that we make to AWS, their input here to see the input struct, delete file system input, update file system, and describe. All of them will have the file system ID that we give to them. All right, so let's head back to our documentation. As you can see here, we have these. Well, this pre-create is not this, yeah. So if it was, like, if it were us having the name as external name, the actual, like, stage name, for example, like in this case we didn't have that, but it was a human friendly name, the actual identifier, we would actually, like, set the external name taken from the user or automatically generated to set the stage name just before creation. But in this case, it's, like, randomly generated by AWS. So we actually set it from AWS to our CR in the post create step.
Right. And something to I guess kind of like harp on there a little bit. So there's a number of different scenarios you could have. Generally, we like for, if possible, the name of the Kubernetes object itself, like in the type meta, or I guess the object meta, excuse me, to match whatever's on AWS, because then when you k describe or k get, right, we have a nice matching there. But you also should be able to choose a different name for it than the one you want. Or maybe you're using external name to assume control of an existing resource. And I believe Muvaffak touched on this earlier. By default, I think the new name as ExternalName Initializer is used with the manage reconciler. And basically what that means is before any of this runs, so basically you can imagine essentially before what's exposed to the user as the reconcile loop actually happens, it's going to go ahead and set that external name equal to the object name unless if that external name is already set. So that kind of pattern enables all of these cases where if you'd like for the name and external name to match, then that will happen by default. If you'd like for the name to be different than the external name, then it'll notice that in the new name is external name and not overwrite it. And then lastly, right, if you want to name it something, but it already exists, then you can put that external name annotation on at creation time. And that's what will be used in this meta.get external name. So kind of a handy pattern there that enables all these different scenarios, which I think we would ideally not like to do, right? We wouldn't have to do this kind of dance with it. But since there are resources that use API calls that require an ID or an ARN or something like that, it's necessary. So I think this is a fairly flexible model considering all of that.
Yeah, I agree. And while you're mentioning that, I implemented the next step as well. So in Crossplane, there is a standard condition in the status that will tell whether a resource is ready to use or not. For some resources, like RDS instance creation actually takes it some time. For example, here it's backup taking some time. So in these cases, we only set conditions if like its state is available. In this case, just creation going through would be enough, is my guess. So I just optimistically set this to available, but we will see when we use it, we will see if there's a creation state for some time, we will use this result of describe and set it properly. But for now, we will just set it as available and see in our test. All right, so these are all the custom parts that we have to do for basic functionality to work. The rest will be better quality, and some of it is actually generated in PRs, latent and is up to date. For now, we will skip these parts and jump to testing our code in actually Amazon account. Cool. So so I will create a. Let me see if I have a cluster already. Okay, so let's delete the cluster. By the way, I will just follow the steps here. Okay, so now let's create a new cluster. And while it's doing that, since we added some fields in custom type parameters, we actually need to regenerate the CRD. So I will just run this again. Okay, we have generated it. We are waiting for cluster to get ready. Cool. CRDs up here. So the next step is basically applying the CRDs. So this is like just for local testing. For actual in-cluster testing, like you need to build the package and push it somewhere and all that stuff. But for local testing, I just go with this approach. Okay, cluster is ready, so I will just apply all CRDs of provider AWS. Cool. And now I am going to run the controller. But I actually want to run it here in my IDE. The command is just same. But so that, like, we can see the actual controller, like reconciliation going through. So I will put one here, and one here, and start it. Oh, and we have to write a YAML, obviously, for this as an example. I will just copy the usual stuff. Let's stop this for now. This will be EFS file system. Example, yes, is one, these are not relevant. So let's see what fields are required. A creation token. Okay. Encryption, chemistry ID. Okay. I think this is enough for a file system to be created. And I will just make this default. So first, as you all know, we need a credential set. So I have a small script here that will go ahead and like create the secret that has my access key and ID. Oh, okay.
My new favorite way to do this, because I'm always like creating the credentials over and over again, which the script works great for that. But is to just cat the creds, my I think it's like home.aws/credentials or something like that, into an environment variable, and then have a provider config that points to the environment variable. And since we're running this controller locally, it's in the context of it, and then just use the credentials from there now that we have support for that as a source. You can also actually just create a provider config that literally points in your local file system, I guess, also to your AWS credentials file. So those are all fun ways to do it.
Yeah. All right, so I am going to create the CR. It's created, but no, nothing is reconciling it. So I will start debugging and see how it goes through the reconciliation. And I can also log into AWS here because we will look at what's going to be there. Okay, cool. It's started. So the first step is to check get external name. Well, actually, we actually made a error here. So it's first thing is gonna check the external name. If it's not given, then it definitely means the resource does not exist. So it will it will just jump to creation phase. However, when we look at object meta annotations, we will see that external name is actually here because it was auto-generated by our setup function by default. But we don't want that for the resources that gets their external name annotation from AWS. So we actually have to overwrite the initializers here. Like for all these cases, you can just look up to other resources. For example, VPC is like such a resource. We can just go ahead and EC2 VPC controller. Yeah, you can see here the initializer. We don't have the tagger for this resource, and I don't want to go into much detail there. Yeah, so we have like a set of initializers by default. Right now, by default, let's see what's in there. It's default provider config. If you don't give a provider config, it writes a default as a name and new name as external name. It just copies the actual name to external name. We're overriding this initializer chain to have only the default provider config. Cool. Since the CR now has the external name, when we look at it, let's say, yeah, so we need to delete this one. I mean, we can just remove the external name as well, but like, you know, no need for that. But originally it doesn't have, since reconciler is not up, annotation should be empty. Yeah, I mean, external name empty. Okay, let's start again. Cool, we just started an external name. Because it's empty, it just returns, and we'll jump right into creation. So here, there is a function that we never touched, and this is like takes CR and sets all the fields of the create file system input. This is like all generated, like step by step. It is like, you know, setting all the fields that we gave. Since we gave like, you know, just one field, it just goes through. Excuse me. Cool. So we pre-create, we did not do that. So right now, this is the actual AWS call. Let's see, and ERR is nil. So these are like the set statements which are not relevant. So post create. Now we are going to go into our own hook. So at this step, CR still does not have the external name annotation. You can see here. Here we will set it, what we got as the ID, and let the manage reconciler know that we have assigned it. So now we are at the manage reconciler. As you can see, ERR is nil. If it is assigned, so it has like a retry mechanism there. Okay, so let's get back. Yeah, so that's completed. So let's see our resource now. Okay, so we see the external name set to actual file system ID. Let's look at it in the AWS console. File systems, and there you go.
Nice.
We've got it up and running. So now it will again check the external name in the next reconcile. Just a second. Now it will find the actual, like, you know, external name and then generate the input struct for like querying its status in AWS, and in the Preobserve we inject, for example, let's see OBJ, you can see file system ID is nil. There's just nothing much, only creation token that we set. So we inject the file system ID, and then now the describe call is made with that file system ID. And in the error, we have a bed request. Request cannot contain both a file system and creation token. Okay, so creation token, I guess it's kind of used like an identifier. So we will just get rid of it here in the Preobserve. So like for these cases, like this is why we have the hooks. So I can just set it to nil and like, you know, be done with it for this like specific query, because file system ID is unique enough. I mean, one could also say like creation token could be used as external name, but like that's not what you see in AWS console or anywhere else. So ID makes more sense there. Okay, so now we need to describe call, error is nil. So here we have like a filter list that we can also override as a hook. But since a file system ID is unique enough, the default one is actually fine. Like the list already has only one element. right? So it's all fine. We don't touch that. And the late initialize we didn't overwrite. This is generated, and this is like no op. So we just like, observation is done. Cool. So in our post observe, actually we set it to available. Let's see if that shows up. Yeah, available,
Nice.
ready to do. The information about like, the current state is in at provider. For example, for some reason, if you need like full ARN, you can actually access it in status. And lifecycle state available. Actually, so there's a status field. So we can use this one to decide whether the resource is ready here in post observe. So I am just going to say if obj sorry, string value obj dot well, it's okay for now. I'll just go to like 0, but it's not very safe. It's fine for now. Actually, these enums should exist like in the generated code. I don't use them much because they're usually not necessary. But yeah, here we have some. So if it's, we can have a switch statement, but I just want to go ahead and do that for now. Okay, only if it's equal to available, set this condition to ready. Cool, so that one is fixed. Let's see if we will come here.
And then really, oh, go ahead. I was just going to say one of the really cool things about composition, or another one of the really cool things about composition, is that you can also define readiness checks on other fields and that sort of thing. And one I was looking at here that might be interesting is it looks like in the status we have mount points or something like that. So if you were potentially in the future using a composition that had a EFS instance in it, as well as something that mounted it, you could do a readiness check on it that said like, this isn't ready until, mount points equals 1 or something like that. And you could have a lot of kind of like custom behavior around that.
Yeah, exactly. Cool. So we have this. So we will test the deletion. kubectl deletes. Actually, just kubectl get manage it to see all the managed resources in our cluster, which should be only one. Delete this resource. Also, you can see the external name menu query with kubectl. So we send the deletion signal and we came here deletion. So in Crossplane, resource is only gone, like it actually attaches a finalizer to lock it. And making the deletion request is not enough for like, for it to disappear. Here we make the deletion request and PRR is nil. So the resource is gone, but we still keep it until the next reconcile. And we see like, hey, this is actually gone, like it's not there. We're getting like 404. Okay, that already happened because we didn't have the breakpoint here. So let's see, yeah. File system, and it's gone. And let's see here. Yeah, it's not here as well.
Yeah, and one of the questions we get a lot from folks is, if I want to guard against doing something like accidentally deleting the Kubernetes object or something like that. There is a deletion policy on all resources, which is part of the fields that just get added to the spec of all managed resources. And so you could say something like deletion policy orphan. And that would mean that Crossplane, when it goes through that manage reconciliation loop when a deletion timestamp is set, it's going to not actually delete the external resource. It'll just clean up the Kubernetes object. So that's a nice way. Obviously, in that case, you have the ability of like losing state between your Kubernetes cluster and the external. But you also have the ability to make sure that, you know, you're not actually going to delete something on AWS from your Kubernetes cluster. And another thing to note on that is if you had deletion policy orphan and you deleted the Kubernetes object and it still exists on AWS, you could just import it again, right? With that external name. So something to keep in mind there.
Yeah, exactly. So I just created a new one with deletion policy orphan to show that. And right now we are seeing like lifecycle state is creating. Once it's available, this condition will be like, you know, ready condition will be true. But until then, we do not report it as ready. Let's wait for the next reconciliation.
One of the things that's been nice since the rate limiting functionality is added in here is typically it will resolve a little bit faster because before we were either just doing a short or long wait. So it would be 30 seconds or a minute. And now it actually, you know, will say like, I think the base delay is 1 second. So it'll, you know, progressively exponentially back off to a minute. And a lot of times resources don't take a full minute. Something like a file system won't take a full minute to actually provision. So it's nice to get that a little faster.
Yeah, I agree. So now we will just test like, you know, deletion with deletion policy orphan. And we will see that like our deletion breakpoint will not be called here. The one that we put there. See, the resource is gone here, but we never called deletion because it's, we like, you know, we are told that we need to keep it, we need to orphan it when the deletion happens. So here it is, and I have to delete it manually. Cool. Awesome. Yeah, I think so. So we don't have much time. I can just go quickly like the rest of the document. So the other parts like for better quality is like one is late initialization. As you can see, we have like, we create the resource, but like there are some spec field parameters that AWS decides for you as default, but you don't see them here because you didn't give them. So late initialization is like, you know, what it does is basically it checks every field and says, if user did not give any value, go check like, you know, what is returned from AWS. If there is some value, go ahead and assign it in the spec for that field. So when you apply, for example, RDS instance, it has like, you know, almost like, I guess, 40 fields. You can create like, you know, two or three fields, like only the required ones. And once you apply it, you will see like, you know, the CR just gets big and like, you know, all fields are populated with the actual values. That's kind of like, you know, useful for like, you know, not ever having to go like to AWS console. A lot of times I just like, you know, don't really need to go there. This is like no late in it. And there are like examples here. But we also have a PR that I will actually automatically, you know, generate that. So after that is merged, I will like, you know, remove this part and like, you know, let readers know about it. And the other part is up to date. So as you can see, we have the update call here, but we never called that because we have to know whether we need to update the resource or not. For example, we don't, if we call it update, like, you know, every reconciliation, AWS like returns an error because there is no change. So we have to detect whether there is a change and what it is. This is why, like, you know, we need to implement that is up to date function that will return a Boolean. And if it's false, we will call like, you know, update with the struct that is generated for it to work. And this is also like, you know, will be generated by a PR that is open, but it's not like, you know, both of them are not really hard. They're just like, you know, plumbing. So they're pretty easy to write by hand as well. And after you've done like, you know, update and late initialization, that's actually like, you know, beta 1 quality CRD now. So when you open the PR, we merge it, and like, you know, after one release, we can actually get it to upgrade it to V1 beta 1, which means even if we make some breaking changes in the future, we will have to like, you know, take care of that either with instructions to update or automatically update it with webhooks. So it's like the the high-level support for that resource. For example, we have like RDS instance and like, I guess, all network resources at V1 beta 1 level. So they're like, safest to use resources. And like, once we get more parts generated, it will be much easier to have a V1 beta 1 level. Like right now, we implemented one in 1 hour. Yeah, I mean, so like, we have this also, the test scenarios that I actually did them like manually, but you can also follow the test sections here to make sure like everything is working. So yeah, I guess that's like the whole thing. I want to go into detail like how actual code generator works, but I guess we don't have much time for that. But like just a quick overview is what it does is like go get that JSON that describes the API with all the shapes and stuff, and like analyze recursively and generate like CRD struct and status from like create call, and then actually like generate the conversion functions that we saw like the generate the ones here, conversions. And when you go to code generator code base, you will see like a lot of Go templates like this one in Crossplane directory here. So this is like for example, Go code set update input. This is like generated in the Go runtime, and then after all of these are generated, it sends the values of these like functions and like other things to Go template to place them, and then save that output file to the directory that we give. So that's like roughly how it works. Like this is our controller template. So as you can see, there are like some like differences between APIs. Like for example, this one was a read many type that it returned like more than one file system in an array. So that needs to be handled differently than let's say read one. For example, when you ask for a VPC, it just returns one VPC. So that's like what's going to be chosen in this template.
Nice.
So yeah, that's I think general overview of like how it all works.
Awesome. Yeah, this has definitely been super helpful. I think I was mentioning to Muvaffak before. I bet a lot of folks will want to take a look at this after the fact, kind of following along as they're implementing their own resources. And maybe, we'll have a follow-up episode as well where we can dive into a little more of how the code generator works, or maybe even get Jay to come on the show and the two of you could run the show.
Yeah, that sounds pretty good. Jay is, by the way, the engineer that I'm working with in AWS, who is leading the code generator project there.
Awesome.
So yeah.
Cool. Well, thanks for coming on, Muvaffak. It's always a pleasure to have you on the show, and it's definitely always super informative and good reference points. So definitely will not be the last time on. But yeah, thanks to everyone for showing up. I see Phil just said this is awesome work, which it certainly is. And shout out to Muvaffak on all the great effort that he's put in here. But thanks to everyone for joining. And since we're getting to the end of the week, everyone have a great weekend. See y'all.